uh, we discussed about the translation. First transformation is translation. Today we will discuss second transformation, that is rotation. And this rotation has two different types of rotation, either in anti-clockwise or in clockwise. Anti-clockwise, anti-clockwise or clockwise. When we rotate our object in a clock direction, if we rotate this object in a clockwise, then it is called clockwise rotation, and it is denoted by r theta minus 1. R theta minus 1 means clock direction is taken as a negative direction. But when we rotate our object in anti-clockwise direction like this, then it is called r theta plus positive rotation. In image processing or in computer graphics, the clockwise direction is taken as a negative, and anti-clockwise is taken as positive. So due to direction, there are two different types of rotation. First is called anti-clockwise, that is in this direction. The notation of this rotation will be r theta plus, and in clockwise it is known as a r theta minus. Now, in 2D rotation, the rotation may be either in 2D or in 3D. 2D means in X and Y direction, and 3D means in X, Y, and Z. So, rotation will be either in 2D or in 3D. And in both cases, we will use anti-clockwise or clockwise. So, first see the definition of 2D rotation. In 2D rotation, an object is rotated by an angle theta. In 2D rotation, one object is rotated by an angle theta with respect to the origin. This angle is measured to be positive for anti-clockwise, that is r theta plus, and negative for clockwise rotation, that is r theta minus. There are two cases of 2D rotation. In 2D, there may be two different situations for this rotation. First is called rotation about the origin by simple transformation, and rotation about an arbitrary point by composite transformation. So we will use either simple transformation or composite transformation. For example, this is our 2D x and y. So it is a 2D plane, and there is an object. If we move this object from this location to some other location, suppose P dash, and this object is shifted to P dash from this origin, respect to this origin, then this distance will be r, and the distance of this object will be also r, but the object is shifted from P to P dash by an angle theta. This is angle theta. This is our angle theta. So when an object is shifted by an angle theta with respect to origin, then this type of case is called case 1, that is rotation about the origin by simple transformation. And there is another case. Suppose this is our 2D plane and an object is placed at this place. Now, if we shift or rotate this P at this place, P dash, but at this time we rotate it from this point. This is our origin, or with respect to this point A. So the distance from this A to P is R, and the distance of this A to P dash is again R, and the angle of rotation is theta. But at in this case the origin is not the origin of xy plane, but it is the origin at point A. So in this case I have rotated the point P, or object from point P to P dash about this A point. So this type of rotation is called case 2. This is called case 2, and this type of rotation is called case 1. In case 1, the reference point is origin, while in the case of case 2, the actual origin is this one, but the point or object is rotated through or about the some other point, that is A, and this A has some coordinate. Suppose it has hk coordinate. Hk coordinate, it means the x value of this A is h, and the y value of this A is k. But in this case the x value of this P, x comma y, the x value of this P is this value, and the y value is this value, from this place to this place. In this case the coordinate of P is xy, but the actual coordinate of this P with this original axis or original frame is x plus h, because this x is from this place to this place. So actual distance at this origin frame, this is our h, and this distance is x. So actual distance on the original frame is h plus x. So we can say the actual distance of this x with respect to this original frame is x plus h. Similarly, the original distance of this y is k plus y, or y plus k. I mean this value. This is our y from this place to this place, and this is from k. So the actual y distance becomes y plus k. This is the difference between case 1 and case 2. We will discuss each one by one. First we see the case 1, rotation about the origin. In this figure, the object is placed at this point P, and this object is rotated by an angle theta, at P dash. So this object is shifted to this place by an angle theta. The distance from this object from the origin is r, and the distance from this at this new place is also r, but it rotate or rotate by an angle theta. So let the point P, xy is rotated by an angle theta in anti-clockwise. The rotation is in anti-clockwise. So at this place we will take the notation r theta plus, because our direction is anti-clockwise. Anti-clockwise. So let the point P, this point P xy is rotated by an angle this theta. It is rotated by an angle theta in anti-clockwise, that is in positive direction with respect to this origin. The vector OP, this is our vector OP. This is our vector OP. Here the point PXY is at an angle phi from the x-axis. Originally, originally this point P is at an angle phi, this angle at an angle phi from the x-axis, and we again rotate this point P by an angle theta. So the angle from this x-axis to this origin point will be this one, and this angle is nothing but the theta plus phi, theta plus phi. So the actual angle of this new location from the x-axis becomes phi plus theta, because the object is at the origin place, or at a source place, is is at an angle phi, and it is rotated by an angle theta. So the actual angle from the x-axis to the new location becomes phi plus theta, that is phi plus theta or theta plus phi. Here the point PXY is at an angle phi. This P point is at an angle phi from the x-axis in positive direction, and the point P dash, that is this point P dash x dash y dash, is an is at an angle phi plus theta. This is our original angle and this is rotated angle. So total angle becomes phi plus theta from the x-axis in positive direction. So we will take the notation r theta plus. Now we represent this coordinate in polar system. As we know, the coordinate of any point, can be represented in either Cartesian coordinate system, Cartesian coordinate system, or polar coordinate system. Polar coordinate system. There are two different types of coordinate system, that is Cartesian and polar. The coordinate of any point in Cartesian coordinate system is denoted by x and y, like this. But in case of polar coordinate system, the coordinate of any point, this P will be represented as r cos theta, or some angle phi, comma r sin phi, r sin phi. Suppose this is our point P and its coordinate is xy in Cartesian coordinate system. The point P is represented in Cartesian coordinate system in terms of x and y. But in polar coordinate system, we will take the distance of this point from the origin. We take the distance of this point from the origin, suppose it is r. Then angle from x-axis to this point is suppose theta, or suppose phi. Then the y value is this one. This is our y value and this is our x value according to the Cartesian coordinate system. So this is our x. It means this value is our x and this value is our y for this point P xy. and the representation of this the coordinate of this point is xy in Cartesian coordinate system. If we want to represent this coordinate in polar coordinate system, then we will use these two terms, r and angle phi. How these terms are related with x? In this figure, this is our right angle triangle, this is our right angle triangle, and this angle is at 90 degree, and this angle is phi. So for this angle, for this angle cos phi, as you know, cos phi, cos phi equal to base by, cos phi equal to base by perpendicular, as we know from trigonometrical concept, base by perpendicular. So in this figure, the base is x and perpendicular is this sorry, cos phi is equal to base by hypotenuse. So in this triangle, the base is x and hypotenuse is r. So we can write it x by r. And if we simplify this equation, x equal to, x equal to r cos phi, r cos phi. And if we take the sin phi, since we know the sine is the ratio of perpendicular and hypotenuse, perpendicular and hypotenuse. In this figure, the perpendicular is y and hypotenuse is r. So we can write it like this, y by r. And if we simplify this, then we get y equal to, y equal to r sin phi, r sin phi. So this p will be represented in terms of polar coordinate system. X becomes r cos phi, r cos phi, and y becomes r sin phi. So this is the another way to represent the coordinate of this point P. Any point can be represented either in Cartesian coordinate system or in polar coordinate system. The Cartesian coordinate system is Pxy and its polar coordinate system is r cos phi and r sin phi. Due to this distance r and angle phi from the x-axis. So we will apply this concept. We will apply this concept to represent this the coordinate of point P and the coordinate of point P dash. So if we take the this value, then the x becomes r cos phi due to the angle. This angle is phi. So the polar coordinate of pxy is equal to pr cos phi and pr sin phi. But the coordinate of p dash, the coordinate of p dash will be the angle from x axis to this p point is phi plus theta, phi plus theta. This is the actual angle of this p dash from the x axis. So in terms of in terms of polar coordinate system, p dash can be written like this, r cos, cos phi plus theta, phi plus theta. And y dash will be represented as r sin, r sin phi plus theta. So This is in terms of polar coordinate system. So this p dash x dash will be represented in terms of polar coordinate system, r cos phi theta and r sine phi plus theta, and the polar coordinate system of this p is r cos phi and r sine phi. We will use these two terms in calculation. Yes. For the exam, you I will discuss in the next class. Oh, yeah. Okay, okay. I will discuss from the next class related to the examination. Okay. This is the fundamental concept required for the image processing. That's why I am showing all these points. So here the point pxy is at an angle phi. This point p is at an angle phi from the x-axis. So this coordinate will be represented in polar coordinate system like pxy equal to p r cos phi comma r sin phi, because x is r cos phi and y is r sin phi. Similarly, the coordinate of this p dash equal to uh, p dash r cos phi plus theta and r sin phi plus theta, and here x dash x dash is this x dash is equivalent to r cos phi plus theta. So r cos phi plus theta, from trigonometry we know cos a plus b is equal to cos a into cos b minus sin a into sin b. So if we put phi at place of a and theta at place of b, then this equation becomes cos phi into cos theta and sin phi sin theta. We know this relation from the trigonometry. So this r cos phi plus theta can be written like r cos phi cos theta and minus sin phi sin theta by using this relation. Similarly, similarly, mm, this r is multiplied with this term, and this r is also multiplied with this term. So we will get r cos phi cos theta and r sin phi sin theta. So we will get r cos phi cos theta minus r sin phi sin theta. And as we know uh, from the previous, this r cos phi is equal to x and this r sin phi is y. So we will put x in place of r cos phi. So if we place x at this place r cos phi, then it becomes x cos theta, and if we place y at this place uh, r sin phi, then it becomes y sin theta. So x dash is reduced to x cos theta minus y sin theta, because we know r cos phi equal to x and r sin phi equal to y from the first equation. From this equation, from this equation, x equal to r cos phi and y equal to r sin phi. R sin phi. So we will put this value at this place r cos phi, and this r is multiplied with this sin phi. So r sin phi becomes y and this becomes x cos theta minus y sin theta, that I have written here. So x x dash becomes x cos theta minus y sin theta. Similarly, y dash is equal to r sin phi plus theta. From this relation, y dash is equal to r sin phi plus theta. So this y dash equal to r sin phi plus theta, and we know sin a plus b equal to sin a cos b plus sin a cos a sin b. So if we put phi in place of a and theta in at place of b, then it becomes sin phi cos theta and cos phi sin theta. So this expression can be rewritten like this: sin phi cos b, sin phi cos b, and cos phi sin b. And this r is multiplied with these two terms, so r sin phi cos theta plus r cos sin theta. And as we know, r sin phi is equal to y, so we will put y at this place. R sin phi equal to y and cos theta, and r cos phi is equal to x. So we can write x at this place. So this y dash y dash becomes this y dash becomes y cos theta plus x sin theta. Thus we get the value of x dash and y dash. X dash is equal to x cos theta from this equation, and y dash equal to x sin theta y cos theta from this equation. And this x dash y dash is the coordinate of the object at the new place, and this x dash y dash is nothing but the rotation of the object by an angle theta in clockwise. The notation of this r theta plus shows that rotation of an object rotation of an object by an angle theta in anti-clockwise. R denotes rotation of an object by an angle theta in positive direction. In positive direction means anti-clockwise. So we will write here r theta plus. So r theta plus becomes x dash equal to this much and y dash equal to this much. Now if we convert this relation in Cartesian coordinate system. So in Cartesian coordinate system, we use two coordinate system, x dash y dash for 2D, and xy is the coordinate of original place, and this is the coordinate at new place. So and the rotation of this becomes x cos theta minus y sin theta, and this x sin theta plus y cos theta from these two equations. Now in this case, the coefficient of x is cos theta, so we write here cos theta, and the coefficient of y is minus sin theta, so I have written here minus sin theta. From this equation, the coefficient of x is sin theta, so I have written here sin theta, and the coefficient of y is cos theta, so I have written here cos theta. It means this equation this equation is converted into matrix form. It is converted into matrix form. Cos theta minus sin theta, cos theta minus sin theta, sin theta, cos theta, sin theta, cos theta in matrix form. And xy, and this xy is the coordinate of the object at original place, and this x dash y dash is the coordinate of the object at the new place. And we know and we know the new place is denoted by p dash, as I have discussed in the earlier class. New point is discussed denoted by p dash, and the original point is denoted by p, and this is our rotation vector. This is our rotation vector. In previous class we have discussed translation vector. At this place we are discussing rotation factor. So rotation factor is r theta plus, and in terms of this r theta plus is written like this. So to get the coordinate of new place, we correlate this relation with p dash equal to p dot r theta plus, r theta plus, and this p denotes the coordinate in Cartesian coordinate system. Coordinate of object at original location in Cartesian coordinate system is x comma y, and the Cartesian coordinate system of this p dash at new location is x dash y dash, that I have shown in the figure. And this r theta plus is equal to cos theta minus sin theta in matrix form, then sin theta by cos theta. So this is our r theta plus, and this is the coordinate of original place, and this is the coordinate of new place. So this is the relation to get the x dash y dash. If we have the value of theta, and the coordinate of point is given, then we can calculate the coordinate of new location with the help of this relation. But in case of CGS, if we convert this equation, if we convert this equation in HCS coordinate system, this is in Cartesian coordinate system. In HCS coordinate system, as I have discussed in earlier class, we introduce a new column, that is h, and the value of h is equal to 1. So this x dash y dash becomes x dash y dash comma 1 in HCS format, and again we introduce new column in this place, that is h, and the value of h is again 1. So it becomes x comma y comma 1 in HCS format, and this is the coordinate of r theta plus in CCS, Cartesian coordinate system. To convert this Cartesian coordinate system into homogeneous coordinate system, we introduce one row and one column, this one row and this one column, and this is called rotation vector. Rotation vector. In rotation vector, the diagonal of the matrix, must be non-zero. The diagonal of the matrix must be non-zero. So we put here one, and we introduce one row and one column extra, one row and one column extra in CCS format. CCS format, this is our CCS format. We introduce one row extra, that is 0 0, and one column extra, that is 0 0, and diagonal must be non-zero, so we put here 1. So after adding this one row and one column in this CCS, this rotation vector converted into HCS form, that is in a homogeneous coordinate system. We will use this concept in all vector, like translation vector, rotation vector, scaling vector, and sharing vector, mirroring vector, etc. At each place we will use this concept. Diagonal must be non-zero in any vector. either in translation vector or rotation vector. So we will put here 1, and we will introduce one row with 0 value and one column with 0 value. So this CCS rotation vector converted into homogeneous coordinate system in this form, and this xy is converted into homogeneous form in this form, and this is converted into homogeneous form in this form. And after getting the homogeneous coordinate system, now we can apply this formula to get the coordinate of any point in the system. If you are given an object that has multiple points, so that all multiple points can be calculated in a single step with the help of this equation. And this equation is symbolically denoted by p dash h. This is the homogeneous coordinate system of p dash. So it is represented as p dash h, and this is the homogeneous coordinate system of p, so it is written as ph. And this is the homogeneous coordinate system of rotation vector, that is r theta plus. So finally we get this equation, and in short terms p dash h equal to ph dot r theta plus. For clockwise rotation, if we, our point is, in this example I have rotated the point in anti-clockwise. I means p is placed here and p dash is obtained by anti-clockwise. If point p is given here and new location is at this place in clockwise direction, then the notation will be equal to this. If this is angle theta, then this angle is denoted by minus theta. So if we put a minus theta at this theta place in this equation, cos minus theta becomes cos theta, sin minus theta becomes minus sin theta, and minus sin minus theta becomes plus sin theta, and cos minus theta becomes cos theta. So this equation this equation is for anti-clockwise, and for clockwise we will use this one. And this equation is obtained from this formula by putting the theta, minus theta in place of theta in this case. And as we know from the trigonometry, as we know, the cos minus theta equal to cos theta, and sin minus theta equal to minus sin theta. So this cos minus theta becomes cos theta, sin minus theta minus sin theta, minus sin minus theta becomes plus sin theta, and cos minus theta cos theta. So this is the uh, rotation vector for clockwise direction by an angle theta. Now we take one example how we will calculate the new coordinate of any object by using this notation. Suppose a triangle is given with different vertices, a equal to 0 0, b equal to 1 1, c equal to 5 2. This is the coordinate of a, this is the b, and coordinate of c is 5 2 about the origin by an angle theta. So since it is given that it is rotated about the origin, so we will use the case 1. And since there is no mention about the clockwise or anti-clockwise, so by default we take the anti-clockwise. If direction is not mentioned in the question, we will always assume anti-clockwise default. And in anti-clockwise we know the rotation vector, and that rotation vector is r theta plus, that I have established earlier, previous. So r theta plus is this much, cos theta minus sin theta cos theta, and this one. And theta in this question, theta is 45 degree. Theta is equal to 45 degree given. So we put 45 in place of theta. So we get cos 45 degrees. Again, sorry, at this place it is sin 45 degree. And sine 45 degree, then cos 45 degree, 0, 0, 1. And as we know, cos 45 degree is equal to 1 by root 2, and sine 45 degree is also 1 by root 2. So r theta plus becomes root 2 by 2, root 2 by 2. If we simplify this 1 by root 2, we multiply root 2 by root 2. So this 1 into root 2 becomes root 2, and root 2 becomes 2. So I have written here root 2 by 2. Similarly, this is again multiplied by root 2 by root 2. So we get this value, and in same way we get this and this. So finally we get the we get the sorry, is at this place it is sine 45 degree. So finally we get the value of r theta plus, and r theta plus is equal to this much. And pH, as we know, P is equal to A, B, C, since it is a triangle. So A has 0, 0, B has 1, 1, and C has 5, 2. The coordinate of C is 5, 2. And if we add one column, that is H column, at this place with value 1, so it becomes 1, 1, 1. This is the coordinate of P in homogeneous coordinate system. So for homogeneous coordinate system, A becomes 0, 0, 1, B 1, 1, 1, and 5, 2, 1. So if we remove this A, B, C, then we get 0, 0, 1, 1, 1, 1, 5, 2, 1. So this is the value of pH, and this is the value of r theta plus. Now we multiply these two terms to get the coordinate of p dash h. So what will be the p dash h? As we know, p dash h equal to ph dot r theta plus. And just I have seen that pH is equal to 0, 0, 1, 1, 1, 1, 5, 2, 1, and r theta plus is equal to this value. So we get this two value, r theta plus this value, and pH this value. So we multiply this with this one, we get this value. If you multiply these two matrices, you will get the value of 0, 0, 1, 0 root 2 1, and 3 root 2 by 2, 7 root 2 by 2, and 1. It is in homogeneous coordinate system, so we will remove the third column. If we remove this third column, then this 0, 0 becomes the value of a dash, and this becomes the value of b dash, and this is becomes the value of c dash. So original figure of the triangle is abc, and after rotation by an angle theta, that is 45 degree in anti-clockwise, this a dash remains the same, but b dash shifted to this place and c dash shifted here. So this is the new location of this triangle by an angle theta, that is equal to 45 degree in anti-clockwise. So by this way we can calculate the coordinate of new location for multiple points by using this formula. This is the actually advantages of homogeneous coordinate system. In Due to this homogeneous coordinate system, we can calculate the coordinate of more than one points at a time. This is the case 1. And now we move to the case 2, rotation about a plane. Now we move to the rotation about the plane. So rotation about a point. This is the case 2, and these two parts or these two cases will be used in our transformation or in image processing topics. So composite transformation, previous case 1 is based on simple transformation, but this case 2 is based on composite transformation. Composite transformation is nothing but the transformation of uh, transformation of combination of two or more than two transformation. If we combine translation with rotation, then this is the concept of composite transformation. If we use only one transformation to get the coordinate of new point, then it is called simple transformation. But to get the new coordinate of the object by using two or more than two transformation, like translation and rotation, translation and scaling, scaling and shearing, or shearing and mirror, or translation, rotation, and scaling, sharing. If we get the coordinate with the help of all these transformation at a time, then it is called composite transformation. And this case 2 is based on composite transformation. In this transformation, we will use two or more than two different transformation for obtaining the new coordinate of the object. We can build complex transformations such as rotation about an arbitrary point, mirror reflection about a line, etc. By multiplying basic matrix transformation, this process is called concatenation of matrices, and the resulting matrix is often referred to as composed transformation matrix. In other words, we can say that a sequence of the transformation matrices can be concatenated into a single matrix. This is an effective procedure as it reduces, because instead of applying initial coordinate position of an object to each transformation matrix, we can obtain the final transformed position of an object by applying composite matrix or to the initial coordinate position of an object. Rotation about a point. First, we will see the concept of this point. Rotation about a point. Our point is our object is placed at this place, and its coordinate is denoted by pxy, and this object is rotated by an angle theta. This is our angle theta, and it is rotated with respect to this point A, and this point A has some coordinate like h and k. In the previous case, this point is at the origin, but now it is not at origin, it is anywhere in the plane, and it is at this place at point A, and the coordinate of this A is h and k, and this object is rotated by an angle theta. This object is rotated by an angle theta with respect to this point from P to P dash. So the distance of this object from this point A is R. This is our R. And the distance of this P dash is again R. In the earlier case, this R is from the origin. But in this case, this R is calculated from this point. So this is the another case, and this case is for case 2. Now this point is uh, rotated by an angle theta about the point A. We have to calculate the coordinate of this point. To calculate this point, we will use the case 1 and we apply some new concept. What are those concepts? First, first we will shift. This is our, suppose this is our one frame, and this frame is shifted to this frame. If we shift this complete system or complete frame at this place, then we will use the translation concept. In translation, we shift the point at different place. So if we shift the object at a different place, then we use translation. And in this case, this whole system is shifted to this origin. If we shift this whole system on origin, then A will coincide with origin, and this A x dash, this A x dash, this line will coincide with OX, and this A y dash vertical line coincide with 0 y. So after rotation, after translation, we can shift this frame at the original frame, that is at origin. Since the rotation matrix r theta is defined with respect to the origin, from the case 1 we got the formula to calculate the, or we got the formula for rotation vector, but that formula is only for origin, and in this case the situation is different. Our origin is at some other point. So first we will shift or translate the whole system to the origin place. So the rotation matrix R theta is defined with the respect of to the origin. We need to set a basic transformation which constitutes the composite transformation to compute the rotation about a given arbitrary point, and that arbitrary point is A, denoted by r theta A. This is the rotation of an object by an angle theta about point A in anti-clockwise. We can determine the transformation r theta A in following three steps. So how we will calculate this rotation vector? Rotation of an object by an angle theta with respect to point A. In the previous case, this is the case 2. This is our case 2. And in previous case, we rotate the object by an angle theta about the origin. This is our origin point. But in this case, we rotate the object with respect to a point that is called A, and the notation of this rotation is r theta A. Now how I will calculate this value? But before calculating this, we know the formula to calculate the rotation by an angle theta with respect to the origin. So we know this formula, and by using this formula we will calculate the formula for this one. To calculate this formula, we will use composite transformation. It means we will apply translation, rotation, both. So first we will translate the whole system, or shift the whole system on the original frame, that is A will coincide with origin, AX will coincide with OX, and AY dash coincide with 0y. This is called translate the point AHK to the origin so that center of rotation A is at the origin, and then perform after shifting this whole system on the origin. We use this formula, perform the required rotation of theta degrees about the origin. So we will apply this formula because this complete system is shifted to the origin. Now it is the case 1. After rotation, we will again translate or shift the translated value at the original place. So at this place we will use translation in positive direction, that is called TV plus. And in the second case we will apply the rotation r theta comma 0, that is case 1. And after rotation we will back the complete system to the original place, so that we will get the coordinate of new position. So translate the origin back to the original position, that is AHK. And this is the concept of translation vector in negative place. This is our positive concept, this is our negative concept. And what is the formula of translation? We know. So to find the rotation of an object by an angle theta about A is r theta A, and it is the combination of first transformation, that is 1, and 1 is nothing but t minus b. Sorry, this is our t minus b, and this is our t plus b. We back the point to the origin. So first is t minus b, and after translation we rotate by an angle theta. Then we again back the system to the original place. So we need translation vector. So we have used translation transformation two times. First in a negative form and second in positive form, and theta is rotation by this. So this is the uh, formula to calculate the rotation of an object by an angle theta about any point A or arbitrary point A. So how we will calculate it? First we will see, this is the concept. As we know, T V minus TV minus. Actually, we know the formula of TV, translation vector. TV is nothing but the 10TX, as I have discussed earlier. 01TY and 001. This is the translation vector that I have discussed in earlier class. And if we calculate the value of t minus b, this is in plus. So to get the t minus b, we will put a minus at this place, 10 minus tx, and this becomes 01 minus ty, and this is 001. And in this case minus tx. So first we have to calculate p dash h equal to t minus b multiplied with rotation r theta, then multiplied with translation vector plus b, and t minus b is this one. So we will write 10 minus tx. At this place tx is equal to h. Tx is equal to h. It is the x coordinate of arbitrary point A, and this is the y coordinate of the arbitrary point A. So this is our h, and this is our, sorry, this is our k. So we put h at this place minus tx, so it becomes minus h 0 1, and this ty is nothing but the k, so in negative minus k, then 0 0 1. So we get this matrix, and this is the formula of r theta that I have discussed in case 1. And for t plus b, we will use tx, and tx is h and ty is k. So we put the value of tx and ty in this formula, we get 10h 01 k 001. So this is the value of t minus b according to the given condition, and this is our r theta, and this is our t plus b. So we are using three different transformation. This is our t minus b transformation, this is r theta transformation, and this is t plus b transformation. It means we are using more than two different transformation to calculate this value. So it is the case of composite transformation. And how we will get this value? So to get this value, first we multiply these two matrices. After multiplying these two matrices, we get this value, and this new value is again multiplied with the third matrix, then we get this value. And in this value, all unknown term theta is known, cos theta, h and k is also given. This is the coordinate of arbitrary point. So all unknown values are given. So if these are given, then with the help of this we can calculate r theta a. Now how can we will apply this formula on our real life? We will take, for that we will take one example. Remember this formula for case 2. This is the formula for case 2. So we will apply directly this formula. Here one problem is given: perform a 45-degree rotation of a triangle. A triangle is given, and the coordinate of that triangle is a00, b11, c52 about an arbitrary point p a1 minus 1. That is, the value of a is equal to 1 comma minus 1. It means the value of h equal to 1 and the value of k equal to minus 1. If we correlate this point with this p 1 minus 1, then according to the above definition, this p is a. So p h k, h the coordinate of x, and k the coordinate of y. The coordinate of x is 1, so it is h, and the coordinate of y is minus 1, so k equal to minus 1. If we put h equal to 1 or k equal to minus 1 in this formula, we will get the r theta a, and the point a is here capital P. So and the rotation theta is given here 45-degree. So we will apply all these things in our formula. If we apply all these values, ph equal to x1 y1, that is 001 in a homogeneous coordinate system, and theta equal to 45-degree, and we have to calculate the r theta comma p, rotation of an object by an angle theta at the point p. And the formula for this is cos theta, that I have discussed earlier, and we put the value of theta 45-degree, the value of h, that is 1, so we put here 1, and k minus 1. Similarly k minus 1 h 1. And if we simplify or calculate all these value, then we will get this value. So this is the value of r 45 degree. Theta is 45 degree, and the arbitrary point is p, with coordinate 1 minus 1, where 1 is the value of h and minus 1 is the value of k, according to the above formula. So we put all these value in the above formula, we get this value. So r theta comma p is calculated. Now we have to calculate p dash h, and the universal formula is p dash h equal to ph dot some vector. So at this place the vector is this value, and this value is given. So pH value is 001. This is the coordinate of ABC in homogeneous coordinate system, and we put this value. Then we put the value of this 45 degree with this one, and then we multiply it. After multiplying we get this value, and after getting this value we remove the third column. So this is the coordinate of A dash, B dash and C dash. The coordinate of A dash is minus 1, root 2 minus 1, B dash is minus 1, 2 root 2 minus 1, and C dash is 3 root 2 minus 1, 9 root 2 minus 1. If we denote it in pictorial form, this is our original figure. After rotation of this object by an angle theta about point p equal to 1 minus 1, we get this triangle value. So this is a way to use the notation. Then we can use the 3D rotation. In 3D rotation we will use three axis x, y, z, and for that we will use the same formula, but one direction will be added, one dimension will be added, and this is the notation to calculate the homogeneous coordinate system along z equal to 0. It means in z plane. Rotation about the z axis, that is z equal to 0 or xy plane. It means this is our x direction, this is our x, and this is y, x, y, and this is our z. So this value is called xy plane. This is our xy plane, and in xy plane the value of y, sorry, this is z. In this xy plane the value of z is 0. The value of z equal to 0 in this case, because the plane is in xy plane. And if we take the this plane, zy plane, in zy plane the value of x equal to 0. In the zy plane the value of x equal to 0. But if we take another value, suppose this plane, sorry, this plane, I mean xz plane, in this xz plane the value of y equal to 0. So if we say z equal to 0, it means we are saying xy plane. Z equal to 0 means xy plane. X equal to 0 means zy plane. Y equal to 0 means uh, xz plane. So there will be three different types of rotation in a 3D rotation. First is called in xy plane. Second is called uh, in xy plane. Second is in zy plane or yz plane, and third one is called xz plane or zx plane. And this plane, xy plane, is denoted by Z0. It is also denoted by Z0, and X0 denotes the YZ plane. YZ plane, X equal to 0. But if we take Z equal to Y equal to 0, if we take Y equal to 0, then it indicates the plane XZ. So there are three different plane where we will find the rotation vector. The rotation vector for this will be different from this, and this will be different from this. So all these three rotation will be different. I will discuss only one part, and other part you will see from the uh, online. I am discussing rotation about the z axis, or z equal to 0 or xy plane. This is our xy plane, and in this xy plane the value of z will be 0, as just I have discussed. Rotation about the z axis is defined by the xy plane. Let a 3D point, this is our 3D point P, xyz. This is our 3D point P, xyz, be rotated by rotated to P dash x dash y dash z dash. This x y z is rotated at this place, P dash x dash y dash z dash. So P is rotated at P dash, and the coordinate of P is x y z, and the coordinate of P dash is x dash y dash z dash. And the rotation is by an angle theta, that is shown here in the figure. Since both P and P dash lie in the xy plane, since this P and P dash lie in the xy plane, that's why the value of z equal to 0. Because in xy plane, just I have seen that in xy plane denotes z equal to 0. Z equal to 0. So the coordinate of this P x y z becomes x comma y comma z is equal to 0. So we can write x comma y comma 0, and since p dash is also in z equal to 0 plane, so x dash y dash and z dash is equal to 0. That's since z equal to z dash equal to 0 due to xy plane. Here p dash equal to x dash y dash 0, and the result of point xy 0, I means this point p is xy 0, making a positive anti-clockwise direction angle theta with respect to z equal to 0 plane. And here pxy 0, this pxy 0, now it becomes px comma y comma 0, and this becomes p dash x dash comma y dash comma 0. So pxyz, in this case, if we put here perpendicular and take the cos phi and r sin phi, then this formula will be written like this: P r cos phi comma r sin phi 0. Similarly, the equation for this, or the coordinate of this P dash, will be written like this: r cos phi plus theta, because the P dash is from the x axis in anti-clockwise is equal to phi plus theta. Phi is the original angle and theta is the rotation angle. So r cos phi plus theta and r sin phi plus theta. And if we expand all these things as previous or as earlier, then this x dash is equal to r cos phi plus theta, and this can be expanded like this, and this phi plus cos phi plus theta is expanded in this form, and this r is multiplied with these two terms, so we get this, and r cos phi r cos phi equal to this one is x, and r sin phi y equal to y. So we put here x and y, so we get this one. And similarly, we can calculate the value of, sorry, we can calculate the value of y dash, and y dash is equal to, y dash equal to r sin phi plus theta. So we write here this one, and after expanding this phi plus theta by using the formula of trigonometry, we get this one. Then we got this, and this is the case. So x dash is this one, and y dash is this one. But z dash is equal to z, and if z equal to 0, then the z dash is also 0. Now if we convert this matrix or this value in SCS form, so we will get x dash y dash z dash, and this is the h value, and h is equal to 1 in homogeneous coordinate system. So if we write this value in sequence of x y z, if we convert this is in x y z, so x y and z, then the coefficient of x is cos theta, and the coefficient of y is minus sine theta, and the coefficient of z, equal to 0. So if we write this coefficient cos theta minus sine theta 0, cos theta minus sine theta 0, this is the value of this one. Similarly, coefficient of x is sine theta, so write here sine theta. Coefficient of y is cos theta, so write here cos theta, and the coefficient of z equal to 0 in this second term, so we put here 0. And in this case, x, the coefficient of x in this third formula 0, plus coefficient of y is again 0, and the coefficient of z equal to 1. So if we put 0 0 1, so we get 0 0 1. Now this is obtained from this rotation z equal to 0, but this one row and this one column is added in this matrix to get the homogeneous coordinate system, and this is the uh, universal formula p dash h equal to ph dot r. At this place, the rotation is about z equal to 0. It means rotation in xy plane for 3D concept. And if we use this formula in xy plane, then we will use this formula to get the coordinate for the new location of an object. And if we use this yz for yz plane, simply we rotate x to y, y to z, and z to x in this formula. If we exchange or interchange the x to y, y to z, and z to x in this formula, then we get the rotation vector for a yz plane or x equal to 0. So after interchanging this value in this formula, and this formula is this one, so if we interchange this, we get this value, and again in this formula, if we interchange this value, we will get this formula for the zx plane. So these are the different types of rotation. And then there is an scaling, and this scaling is nothing but the resizing the object. This is used to resize the object. If you want to increase or expand the size, then the value of scaling will be greater than 1, and if we want to reduce the size of the object, the scaling factor will be less than 1. and if the value of scale is 1, then size will remain same after transformation. So this is the main concept. And this scaling is in 2D. There are three different scaling: sx, sy, sxy. But in case of 3D, there are a number of sx, sy, sz, sxy, sxyz plane, sxzx plane, then sxyz. So the scaling factor, this S1 lies between 0 and 1. If the value of less than 1, then the size will be reduced, and if the value of this s is greater than 1, then size will be increased. And if we scale the x axis, then this scaling is denoted by sx. If we scale in y, then this scaling is denoted by sy. And if we scale in x and y both, then it is called sxy. So we will use these three different symbols. So for case 1, if we want to scale or increase or decrease the object in x direction only, not in any other direction, then the scaling vector will be sx. And in this case the x value, if point p is given with coordinate xy, then the new coordinate of p dash x dash y dash will be calculated. With the help of this, x dash will be multiplied by this sx value. So if we multiply this sx value, then x will be scaled in x direction, and y dash remains same. Y dash remains same. So x dash y dash equal to xy, and it is x0 sx001. In SCS form, it is sx00010001, and coordinate becomes x dash y dash 1 xy 1. The formula is this. So from beginning we see, if we are taking the scaling in sx only, then x dash equal to x into sx, and y remains same, so 0 into y. And for y scaling, y dash y dot sy, and x, the coefficient of x equal to 0. For sx, this equation will be used, and for sy we will use this equation, and for sxy we will use both these equation. If we use this equation, we will get sx comma 0, sx comma 0. So we apply this 0, this formula with a homogeneous coordinate system, then we will get sx 00010001. And for sy we will use the second formula, that is x y equal to xy dot sy, and from this formula we get this one. And this is in ccs form. In scs form it is like this. And if we use the both direction or both axis, then x is written as x dot sx, y is written as y dot sy. Then scaling in x is sx, scaling in y is sy, and it is in 2D. In SCS form, we add one row and column, and diagonal must be non-zero. These are non-zero, but if we put extra row and column with 0, then this becomes 0. But we have to write here 1, so it is 1. And this is the scaling factor. This is the scaling factor for xy both direction. Now in 3D, like rotation, there are a number of different scaling in x direction, in y direction, in z direction, then xy plane, xz plane, then yz plane, etc. For x only, we will use this formula. If we take the scaling Sx, we will use this formula Sx 0 0 and y dash equal to 1. So 0 1 0 0 1 0 and z is equal to z. So 0 0 1. This is in Euclidean form. If we convert it into SCS form, then it is equal to this one. If we use the scaling in sy, then we will use y dash equal to y dot sy, and other terms remain same. So 1 dot x 0 0 0 and 0 y 0, then 0 0 1. We use this coefficient to get the vector, and that is this one, and in homogeneous form it is equal to this one. For sz, we will use this formula. All these formula will be obtained uh, from any book of the image processing or coordinate system. So you see or try to know about the scaling yourself. These are the different scaling, and this is the sharing. We will this I want to discuss about the projection. From the next class we will discuss the image processing. So what is projection? Projection is nothing but, suppose this is our xy direction. This is our xy plane, and if we place a rod at this place, this is our rod, this is our rod or any stick. If we draw the perpendicular line on x axis, if we draw the perpendicular line on the x axis at the end of this rod or stick, we get, this is our a b. This length of this rod is ab, but if we draw two perpendicular line on this x axis, then this a dash will be represented as a dash, and b is represented as b dash. So a dash b dash becomes the length new length of rod AB along the x-axis. So this A dash B dash is the length of this AB, but the length of A dash B dash is less than AB, because this rod is inclined. If we draw like this, if rod is horizontal, parallel to the x-axis, then the length of AB, or length of rod AB will be same. This A dash is equal to A and B dash equal to B. But if the rod is inclined, then the length of this object will be less than the length of original rod. So this concept is called a projection. This concept is called projection. If we project this rod on y-axis, so for that we draw two perpendicular line from this n to y, and this is the a double dash, and this is the b double dash. Again, a double dash and b double dash is less than ab. So The projection of AB on x is a dash b dash, and the projection of AB on y axis is a double dash b double dash. In both cases, the length of this original rod is less than after the projection. But if the rod is not inclined, in that case the projection will be equal to the length of the rod, or it may be zero. It may be zero because if we project this A or B on y axis, then A and B both are coincide. So the length of AB becomes zero. This is the charming of this projection. After projection, we get the either equal size of the image, or we get the less size of the image, or it could be equal to zero and it may be larger than the original shape or original size. So this is the concept of projection. But in real, mathematically, the definition of projection is given: a mapping of 3D object onto 2D viewing screen. The mapping of 3D object into 2D plane or 2D viewing screen. The 2D screen is known as a plane of projection or view plane, which constitute the display surface. Projection rays determine the mapping called projectors, and geometric projections of objects are formed by the intersection of lines called projectors with a plane called the plane of projection. From this figure, this is our plane. This rectangular box is our plane, and this plane is known as a view plane or plane of projection. And this is our frame x, y, and z. This is our frame. This plane is placed in the first quadrant of this frame. This plane is placed in the first quadrant of the frame, and an object is placed at this point P, whose coordinate is xyz. Then the perpendicular line from this point on the plane or on the view plane or plane of projections is called the image of this P, and the coordinate of this P at this on this plane is P dash x dash y dash z dash, and this perpendicular line is known as a projector. This perpendicular line is known as a projector. So this is our projector, this is our object, this is our view plane, and this is the image of this object, and this line is the projector. This line is the projector. So there are different types of component. First is called object, second is called view plane, or sometimes it is also known as projection plane, and there are projector. I have given the example of rod for the projection. This is our rod, and this vertical line intersect with this x line. So the coordinate of A made at this place with name A dash, and the perpendicular line intersect at x axis at B dash. So B dash is the new point of this B, and this A dash B dash is the image of this AB, and this vertical line or perpendicular line is called the projector. This is our object, and this is our image, and this image is placed on the x axis, so it is in xy plane. but this xy plane may be different than the xy plane. In this case, our view plane is rectangular in xy plane, but in xy plane it is another type of plane. Xy plane is like this, but this plane is inclined to the xy plane. So this is our another type of xy plane, and this is our object, the image. This is our image, and this is the projector. The source place is called perspective sorry. Now we see this definition. Projections are lines from the arbitrary point called the center of projection. These projectors can be drawn from the arbitrary point, and this arbitrary point is called center of projections. Projections rays determine the mapping called the projectors. Geometric projections of the object are formed by the intersections of lines called projectors with a plane called the plane of projection or view plane. Projectors are lines from the arbitrary point called the center of projection, COP, center of projection. Through each point in an object. This is our different points of the object. The following figure shows point P. This is our point P, XY, in 3D, XYZ coordinate mapping into its image P dash X dash Y dash Z dash in the view plane, and this is our view plane. If the COP, center of projection, means source of these projectors, is located at finite point in the 3D space, the result is a perspective projections. And if the COP is located at finite position, then all the projectors are parallel, and the result is called parallel projections. In previous class, I have discussed the two types of projections, basically perspective and parallel projection, and third one is other projections. This is the concept. This is our COP, center of project, and yeah, okay. We will discuss this point in the next class. Okay, okay. We will discuss this in next class. Please switch on your camera to take the screenshot. Okay, thank you. We will meet tomorrow.